Example 2 in lesson 4.7 asks us to find the missing sides and angles of an oblique triangle, so a non-right triangle, when we are either given angle, angle, side, angle, or side, side, angle. When given those combinations of sides and angles, we use what's called the law of sines. Law of sines is the sine of angle A divided by A is equal to the sine of angle B divided by B is equal to the sine of angle C divided by C. Now, one thing I always like to do each year is to go through a proof so that you can see where these formulas are coming from, okay? So once again, take out a scrap sheet of paper or use the back side of the part that we use for the area of a triangle. And this is our proof for the law of sines. Where is this information coming from? Okay, once again, we're going to draw a non-right triangle. So an oblique triangle. Okay, so here's my triangle, and I'm going to label the angles, angle A, angle B, and angle C, which means we have side C, we have side A, and across from angle B is side B. Now, the law of sines occur when we know a combination of sides, one of those being angle, side, angle. So assume we know the measure of angle A, we know the measure of angle B, and we know the value of side C. Okay. Well, if we know the measure of angle A and angle B, we can add those up and subtract from 180. We automatically know the value of angle C. So the only parts we're really missing is side A and side B. So I need to figure out, how can I find side A and side B? Well, keep in mind, the only thing that we've really talked about up to this point are right triangles. So just as I did with area, I'm going to draw in my height so that this can create two right triangles, okay? The height is key to coming up to the law of sines, okay? So if I look at this left triangle and I know the value of angle A, then I know that the sine of A is the opposite side to the hypotenuse. So I know that the sine of angle A is equal to the height divided by side B. Okay. Now, if I look at the triangle on the right, I'm going to know the value of angle B, so I know that the sine of angle B is equal to the opposite side, which is the height, divided by the hypotenuse, which is side A. Now, if I look at my two equations, they have one value in common, and that is h. So I'm going to solve both of these equations for h. For sine of A equals h divided by b, I can multiply both sides by b. So I know that b times the sine of A is equal to h. And for my right equation, sine of b equals h divided by a, I'm going to multiply both sides of a. So we have a times the sine of b is equal to h. So notice both of these equations are equal to h. So think about when we use substitution back in Algebra 1 and Algebra 2. If these both equal h, then these are equal to each other. So what I know is that b times the sine of a is equal to, I'm going to replace a sine b for h because they're equal, so a times the sine of b. Okay. Now, I'm going to multiply the left side by 1 over b and the right side by 1 over b. This is the same thing as dividing both sides by b. Okay, so if I divide both sides by b, then I have the sine of a is equal to a times the sine of b, all divided by b. That's in the denominator. Now on the right side, I can divide both sides by a, which is the same as multiplying by the reciprocal 1 over a. Okay. So I have 1 divided by a times sine of a. This is the sine of a divided by a. Okay. On the right side, a times 1 over a cancels. So I have the sine of b divided by b. This, my friends, is the formula for law of sines. So this is an example of an algebraic proof. When you get into higher level math classes, especially calculus and beyond, you will be spending time deriving a lot of the different formulas and rules that we use to solve problems. Okay, so this is the law of sine. Now we're going to use the law of sines to solve the following oblique triangles. Now when we say solve the triangles, so we're looking at example 2 now, solve the triangles, that means find all missing sides and angles. Find all missing sides and angles. Okay, so letter A, together. I recommend drawing your triangle so you can figure out what you're given and what you need to solve for. So I'm going to create a triangle. I'm going to label the angles A, B, and C in whatever order you wish. And just understand the sides opposite will be small a, small b, and small c. So I'm given angle A at 42 degrees. I'm given angle B at 63 degrees. And I'm given side C, which is opposite angle C, at 15 centimeters. So notice I'm given 2 sides and an included angle. That is angle, side, angle. And with this information, I will use the law of sines to find side A, side B, and angle C. Now, angles are the easiest. Not sure why the focus is kind of going out. There we go. Angles are the easiest because all the angles in the triangle add up to 180 degrees. So angle C can be found by subtracting subtracting the sum of angle A and angle B from 180. Okay, so on your calculator, we're going to take 180 minus 42 minus 63, so angle C is 75 degrees. Now, once you have a value, we can plug it in to my picture and I can use that to help me solve problems. Okay, now, I'm given angle C, or I know angle C, and I was given side C. So when I use the law of sines, I definitely have to use angle C and side C. So I know that the sine of 75 degrees, all divided by side C of 15, is equal to, and I'm going to pick an angle, I'll start with A, so that's the sine of 42 degrees, all divided by side A. We have a proportion, so we're going to cross multiply and solve this for A. So if I cross multiply, we have A times the sine of 75 degrees is equal to 15 times the sine of 42 degrees. We would divide both sides by sine 75 degrees. And I need to solve for side A. This lesson is a very good lesson on just practicing how to use your calculator. So I'm going to multiply, this cancels. So I'm going to multiply 15 times the sine of 42 degrees. Make sure you close that parentheses. You can hit equal to, and then we're going to divide that by the sine of 75 degrees. Close your parentheses and hit equal to. Okay, we're going to round to the nearest tenth. So side A is approximately 10.4 centimeters. We do not round until the very end. Now I'm going to use the same process to find side B. Now because side A is an approximate value, I would stick with just using our side C at 15, and we'll get an answer that's more exact. All right, so again, to find side B, I'm going to use the sine of 75 degrees, all divided by 15 is equal to, now angle B, so I have the sine of 63 degrees, all divided by side B. And cross multiply, so I have B times the sine of 75 degrees is equal to 15 times the sine of 63 degrees. And I will divide both sides by sine of 75 degrees. Okay, that cancels. So B is equal to, I'm going to take 15 times the sine of 63 degrees, close my parentheses and hit equal to, and then divide that by the sine of 75 degrees. And the length of that side is approximately 13.8 centimeters. Very good. So this is how we use the law of sines to find missing side lengths and angle measures. Now I would like for you to pause the video, try letter B. When you're ready, hit play and check your answer. Okay, so in letter B, the first thing I'm going to do is draw my picture. So I have angle A, angle B, and angle C. Now I'm going to plug in what I know. Angle B is 37 degrees. Angle C is 88 degrees. Side B is 33 feet, which means I need to find side A. I need to find side C, and I need to find angle A. Notice this is angle, side. When given this combination of sides and angles, I can use the law of sines. I'm going to start with angle A this time. And I'm going to subtract angle B and C from 180 degrees. So I would add up 88 plus 37. And subtract that from 180. So I have 180 minus 88 minus 37. So angle A is 55 degrees. Okay. Now I'm going to use the law of sines. I'm going to fill in 55 for A. Now, I have to use angle B because I know both the angle and the side. Okay, so when you know both the angle and the side, that has to be one of your ratios. So I know the sine of angle B, or the sine of 37, all divided by side B, which is 33, is equal to, now I pick another angle. So I'll start with A. A is 55 degrees, so I have the sine of 55 degrees, all divided by side A, which is unknown. And I'm going to cross multiply to solve for A. So I have A times the sine of 37 degrees is equal to 33 times the sine of 55 degrees. Okay. I divide both sides by sine of 37. Okay, so A is equal to, so I go 33 times the sine of 55 degrees and close my parentheses. And I divide that by the sine of 37 and I get 44.9. So side A is approximately 44.9 feet. Okay, now I need to find side C. I'm going to use a different color just to kind of separate my equations. So I would have, I'm going to keep angle B and side B. So sine of 37 degrees, all divided by 33, is equal to, I have the sine of 88, all divided by side C. Okay, Once you practice enough, outside of writing down your equation, the work I'm going to require is minimal because a lot of this can be done on a calculator. So when I look at this, I know I'm going to take 33 times the sine of 88 degrees, close my parentheses, and then I would divide that by the sine of 37 degrees. So you're welcome to write out the steps and show your work. You're also welcome just to plug this in your calculator. So I know that side C is approximately 54.8 feet. Okay, please email me if you have any questions that have not been answered. Okay, and now you're going to open up your textbooks and you're going to try a few problems that go over example 1 and example 2 from 4.7.